My name is Caroline Miller, and today I'm going to be completing a tutorial to show you how to find all the biotin biosynthesis genes in the E. coli strand MG1655. So to begin, if you're like me and you're doing this from off campus, I first connect to the UF Wi-Fi, as it's most likely you're going to be needing to look at, well, it would help if I could insert my password correctly, but you're going to most likely be needing to look at different reviews if you're looking at to go one by one for each gene in the pathway. So it's a good idea to just go ahead and be connected whenever you're starting anything with this class, as I'm sure you already know. So to begin, open Chrome, and probably like me, you already have the NCBI bookmarked on your homepage, so go right there. And we're going to want to start with PubMed. And so with a task like this, for most things in this class, it helps to just try many different things, and PubMed is always a good place to start. So here I already have it in my clipboard, so I don't have to attempt to type it out, but this is what we're looking for: E. coli biotin synthesis. So many review papers will have figures that have the entire biosynthesis pathway mapped out, and it will have all the genes that we're looking for. So if you're wanting to go one by one, this is a good way to do it. So you already want to click on review. So we're looking at review papers. And these are more comprehensive articles that are more likely to have a complete figure of the entire pathway. Additionally, we want to make sure that we're looking thoroughly through the results. And as you can see, I've already clicked on this one. So advances in synthesis of biotin and assembly of lipoic acid. There are multiple different things that will come up. And again, you can spend time trying to refine your search field to get more specific results. But again, if you're just starting in the beginning, you're going to just kind of want to look through. This doesn't look right. This doesn't look right. Like a lot of this, you just kind of have to sort through. But I mean, again, it'll kind of bold here, of course, with your search term, but this is what we want to look for. So go here, and this is a little more up to date from some of the tutorials that are on Canvas, of course, since this is recent 2018. And looking here, you can go to the full text links, and this is going to be the full article. So PubMed most likely will have links to where the journal article was actually published. And so this is the link to Science Direct. And again, if you are already connected to, this is why I encourage you to already be on the UF Wi-Fi, because through UF, as you can see here, you already have access to many journal databases and journal articles. So we can see here, looks right, blah, 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 biotin synthesis in E. coli. So looks promising. So as the tutorial showed, you can go through and go to the figures. And as you can see, these are some of the enzymes or genes that you're going to be wanting to look for. So then you know, okay, this is a part of the pathway. These are some of the things along the way that I need to get the EC number and the sequence for. So again, you can just kind of look through, and you know at least you're going to get some of the ones you want. So BioC, for example. So let's just start there. Again, there are multiple different review articles you could have clicked on and look through. Let's look at this. Full text links, figures, BioC, BioH, see all of these right here. So we know this is more or less all the ones we're going to need for this assignment, at least. Figure 1. So again, you can just look through, but then if we want to get each individual one in order to get, again, the specific EC number and so forth, sequence, we're going to go back to PubMed, but now we're going to protein, and we can look up, say, BioC and MG1655. So that's the E. coli strand that we're specifically looking for. So here, as you can see, I've already clicked on this, and we can always click on RefSec to get a non-redundant result list. Go here, this is the strand we want, And again, if you're going one by one, this is a way to do it. So if we scroll down to protein, we can get the EC number, which is what we need, and then the gene name, which is what we also need, and then the sequence is the FASTA sequence here. And again, these can all be inserted in an Excel file, but there must be a more efficient way to do this. So if we go right to UniProt and simply type in E. coli, which is what we're looking for, and if we are looking for the biotin synthesis pathway, let's go under pathway. And as we saw here in the review articles, which will be very helpful, this is a cofactor, so that should stand out to you. Cofactor, let's see, biosynthesis, cofactor biosynthesis, so click on results. And then if we are looking for this one in particular, E. coli, we now have a much more refined search, and we can go to columns to specifically get what we need. So we need EC number, gene names, sequence, protein names, all things of interest to us. Of course, there's many more you can look through, and then you can reorder them if you like. Save. And then we can simply download in an Excel file, compressed. Then we want to open this. And then if you have the newer version of Excel, it might tell you that some of the content was deleted or worked on through Excel, but it should be fine. Oh, I did not open it. Just click yes. There we go. And then we have this all here with what we need. And so there are all the sequences, and this is a much more efficient way. So I hope this helped. And there, again, as you can see, there are multiple different ways. Most of them involve quite tedious or going a little bit slower through one by one, but there is a much more efficient way with UniProt. So again, you can always just try different ways to do things. Thank you.